Hello everyone, I'm Sean Esterly with the National Renewable Energy Laboratory, and welcome to today's webinar, which is hosted by the Clean Energy Solutions Center in partnership with the Global Buildings Performance Network. Today's webinar will present the current status and key areas for international collaboration in building energy code implementation and compliance, and the experience of code implementation in China and the U.S. And one important note of mention before we begin our presentations is that the Clean Energy Solutions Center does not endorse or recommend specific products or services. Information provided in this webinar is featured in the Solutions Center's resource library as one of many best practices resources reviewed and selected by technical experts. And I just want to go over some of the audio and webinar features for you. You do have two options for audio. You may either listen through your computer or over your telephone. If you choose to listen to your computer, please select the mic and speakers option in the audio pane. Doing that will just help eliminate echo and feedback. And if you choose to dial in by phone, please select the telephone option, and a box on the right side will display the telephone number and audio pin that you should use to dial in. If anyone is having technical difficulties with the webinar, you may contact the GoToWebinars help desk at 888-259-3826. And we encourage anyone from the audience to ask questions at any point throughout the webinar. To ask a question, simply type it into the questions pane and you can submit it there. If you're having difficulty viewing the materials through the webinar portal, we will be posting the PDF copies of the presentations to cleanenergysolutions.org/training, and you may follow along as the speakers present. Also, an audio recording of the presentation will be posted to the Solutions Center training page within a few days of this broadcast. And we are also now adding the recordings to the Solutions Center YouTube channel, where you'll find a nice list of other webinars that you can listen to, as well as video interviews with thought leaders on clean energy policy topics. Now, today's webinar agenda is centered around the presentations from our guest panelists, Jonah Steinbuck, Meredydd Evans, Chen Peng, and David Cohan. And these panelists have been kind enough to join us to discuss the current status and key areas for international collaboration on building energy code implementation and compliance. Before our speakers begin their presentations, I'll provide a short informative overview of the Clean Energy Solutions Center initiative. And then following the presentations, we will have a question and answer session where the panelists will address questions submitted by the audience. Mr. Peter Graham, Executive Director of the Global Buildings Performance Network, will also be joining us for the question and answer session. And then finally, we will close with a brief audience survey. Now, this slide provides a bit of background in terms of how the Solutions Center came to be formed. And the Solutions Center is one of 13 initiatives of the Clean Energy Ministerial, which was launched in April of 2011 and is primarily led by Australia, the U.S., and other SEM partners. Some outcomes of this unique initiative include support of developing countries and emerging economies through enhancement of resources on policies relating to energy access, no-cost expert policy assistance, and peer-to-peer learning and training tools, such as the webinar you're attending right now. And there's four primary goals for the Solutions Center. The first goal is to serve as a clearinghouse of clean energy policy resources. Second is to share policy best practices, data, and analysis tools specific to clean energy policies and programs. And third, the Solutions Center delivers dynamic services that enable expert assistance, learning, and peer-to-peer sharing of experiences. And then lastly, the center fosters dialogue on emerging policy issues and innovation from around the globe. And our primary audience for the Solutions Center are energy policymakers and analysts from governments and technical organizations in all countries. But then we also strive to engage with the private sector and NGOs and also civil society. This slide provides a bit of information on one of the marquee features that the Solutions Center provides, which is its no-cost expert policy assistance known as Ask an Expert. And the Ask an Expert program has established a broad team of over 30 experts from around the globe who are each available to provide remote policy advice and analysis to all countries at no cost to you. So, for example, in the area of buildings, we're very pleased to have Cesar Trevino, leader of the Mexico Green Building Council, serving as one of our experts. So if you have a need for assistance in building efficiency or any other clean energy sector, we do encourage you to use this valuable service. And again, it's provided to you free of charge. So if you have a question for our experts, please submit it through our simple online form at cleanenergysolutions.org/expert. Or if you want to find out more information on how Ask an Expert can benefit your work, please feel free to contact me directly at sean.esterly@nrel.gov or give me a call at 303-384-7436. And we also encourage you to spread the word about this service to those in your networks and your organization. So now I'd like to provide brief introductions for today's panelists. Our first panelist is Jonah Steinbuck, and Jonah is a Climate and Clean Energy Fellow in the Office of International Affairs at the U.S. Department of Energy. He serves as the U.S. lead for the Building Energy Efficiency Task Group of the International Partnership for Energy Efficiency Cooperation, and his work primarily focuses on advancing clean energy and energy efficiency policy through international forums such as the IPEC, the Clean Energy Ministerial, and the G20. And following Jonah, we will hear from Meredydd Evans, a senior staff scientist at PNNL with over 20 years of international energy policy and finance experience. She has worked on energy efficiency and clean energy policies and projects in numerous countries and currently manages a program on international sustainable energy at PNNL. That includes efforts on building energy efficiency codes and retrofits. She spent 4 years in Paris, seconded to the IEA, during which time she served as the acting head of the non-member country division. And our third speaker is Chen Peng, who will be joining us from the Center for the Science and Technology of Construction. And then our final presenter today will be David Cohan, the Building Energy Codes Program Manager at the U.S. Department of Energy. David has over 20 years of energy efficiency experience in a variety of capacities, including evaluation and program design. For the last decade, he has worked on development and implementation of building energy codes to mandate minimum efficiency levels for all new buildings constructed in the U.S. He's especially focused on ways to increase compliance with codes so that potential energy savings turn into realized savings. And then finally, Peter Graham will be joining us for the question and answer session. And Peter is currently the Executive Director of GBPN. And Dr. Graham previously served as the Technical Advisor and Coordinator of the United Nations Environment Program Sustainable Buildings and Climate Initiative. And so with those introductions, I'd like to go ahead and now welcome Jonah to the webinar.
Thanks very much, Sean, and good day to everyone, and thank you for joining this webinar on building energy codes. As Sean mentioned, I'm Jonah Steinbuck from the U.S. Department of Energy, and I serve as the U.S. lead for the IPEC Building Energy Efficiency Task Group. And this task group supported a project over the past year on the exchange of code practices and experiences that you'll hear about today. As some of you are familiar, IPEC, the International Partnership for Energy Efficiency Cooperation, is an international forum comprised of 16 major economies, collectively responsible for about 3/4 of global GDP and energy use, and it's dedicated to accelerating the adoption of energy efficiency policies and practices through dialogue and action within a range of different energy efficiency initiatives. One of those initiatives is the Building Energy Efficiency Task Group, or BEAT, and through BEAT, governments work collaboratively to research and support the development of effective building energy efficiency policies. This task group was originally chaired by Australia starting in 2012, and it's currently co-chaired by Australia and the United States, and it engages the members and guest governments of IPEC and the G20 economies shown on this slide. Over the past few years, the BEAT has conducted projects on building energy rating systems. We've looked at opportunities for international collaboration across a range of building energy policy areas. We've looked at building energy performance metrics, and the webinar topic today, building energy codes. Next slide, please. So the codes project started in last fall, fall of 2014, as a collaborative effort of the national governments engaged in the IPEC BEAT, as well as the Global Buildings Performance Network and the Pacific Northwest National Laboratory. And this followed on an earlier project that showed that building codes were a key area of interest for international collaboration among IP government energy efficiency experts. The project focuses on identifying the key areas for international collaboration on building energy code implementation. So essentially, we're trying to better understand how to realize greater energy savings from codes. And as a first step, the focus has been on sharing building energy code approaches and experiences. As part of this project, we developed a web portal to support more efficient international knowledge exchange on building energy code implementation. This provides information, experience, resources, and as well as a network of codes experts from around the world, and I encourage you to check it out. The web link is shown there, www.gbpn.org/beat3. And we very much look forward to continued collaboration on codes. We expect this work to continue, and hope that you can continue to join us in this effort going forward. There's going to be a webinar coming up on November 12th to further explore approaches to implementing building energy codes, and hope you can join us for that. And with that introduction, let me turn it over to Meredydd Evans of the Pacific Northwest National Lab for the next segment.
Thank you, Jonah, and welcome everyone this morning or this afternoon, depending on where you are. I will provide a brief overview of the information that we learned about building energy codes globally in developing the web portal, and also just more broadly in implementing the BEAT3 project. And I think, it is really helpful to understand what is going on in other parts of the world, because there are a lot of potential lessons that countries can learn from each other. So the purpose of this webinar is to provide the groundwork and the framework so that as we move forward, people have a better general understanding of what flavors of codes exist. So today I will provide a brief introduction and talk about the different types of codes that exist around the world, talk about what codes typically cover, also the implementation process and the different institutional roles that may exist in different parts of the world. Briefly, I'll talk about code revision schedules, and then provide some conclusions. So what is a building energy code, or a building energy efficiency code? We feel they're mandatory requirements on building design and construction for improved energy performance. It's minimum requirements for the energy efficient design and construction or renovation of new and existing buildings. I think it's also important to think about the fact that these are actually requirements, and that distinguishes codes from building performance labels that explain how a building performs or may perform, but doesn't typically actually require certain features in the building. What do codes cover? Codes, typically one of the first things that will show up in codes are elements related to building envelopes, things like thermal loss through the walls or the windows, which is U value, solar heat gain through windows, and window to wall ratio, air tightness, shading, building orientation. The latter two are newer. Many countries don't have them in their codes. Lighting is often in building energy codes. A few countries have it in a separate document, but very common because it's so cost effective. HVAC requirements are typically in codes, as well as requirements regarding service water heating. This is not an exhaustive list. It's just to give you an idea of some of the major elements in terms of the technical measures that typically show up in codes. And some countries have much more limited codes than this, and they may only have a code that focuses on envelope, for example. Increasingly, countries are including post-completion requirements in their code. So, for example, commissioning and blower door tests are two common examples. There are differences across countries in the scope of the code. So what kinds of buildings get covered? You can see it in terms of the size threshold of buildings. In some countries, any building or any building that gets space conditioning is required to comply with the code. In other countries, there may be a threshold that's quite high, of say 1,000 square meters, particularly when countries are just beginning to implement the code. But actually not only, I mean, there can be some surprising differences in this area. And ultimately, it has a large impact on just how much of the new building stock is covered. Types of buildings, some countries limit their code to certain types of buildings. A good example of that is India, which has a code that covers only large commercial buildings. Brazil actually doesn't technically have a code. They have a labeling program focused on government buildings. So then one question people often wonder about with codes is the code mandatory or voluntary? And it's a really, excuse me, it's a very tricky question. So we were using a working definition that a mandatory code is an implemented code. And it's important to think through the range of factors that affects whether the code ultimately is implemented. First is whether the code has been adopted in all or most jurisdictions. That's particularly important in countries that have a federal form of government, where the national government can't just simply say, we're adopting the code. Next is the extent of compliance checks. So people tend to comply more if you're checking compliance. Also the ease of compliance. If the code requires really complicated formulas and calculations, it might be difficult for people to comply with the code, or they may not have the skill set to date based on the type of code that a country has adopted. And it's also important to note that some codes, in fact most codes, provide flexibility in their compliance approach, so that if somebody wants to have more windows, for example, they can if they compensate for that in other parts of the building. That fact alone, it doesn't make the code voluntary. It just provides a framework that allows people to ultimately achieve greater energy savings because they do have that flexibility, I think. So in the end, it's challenging to categorize countries definitively, and the most important thing at the end of the day is to work for broad implementation. Then looking at the codes in terms of their different compliance approaches, there are also quite a few differences across countries. Typically, the first thing that countries will start with is a prescriptive code, which has specific rules on individual building components, like on the windows or on the kinds of how much insulation may need to be in the building, and so on. A next step would be to provide some simple trade-offs between building elements. So, for example, between elements of the envelope. And many countries, although not all, do have some kind of simple trade-off. Some will use a calculated formula, some may use tables. Then moving on from that, a lot of countries increasingly are encouraging or requiring simulated performance to understand how much energy the building would likely use. And there are different approaches here as well, where it may be in comparison to a theoretical reference building that would comply with the prescriptive measures, or it might be compared to a specific set target. And that could be expressed in energy used per square meter, for example, or maybe in carbon dioxide emissions per square meter. And that's one area where there's potentially some interesting collaboration between countries because of the different approaches. Some countries have a totally different approach, and that is a point system. It's quite common in some will add up their points, and at the end of the day they have to have a certain number of points to meet to pass the code, and if they exceed that they may be able to get some low interest loans or other incentives. And then finally there's a new concept called an outcomes-based code that would require people to demonstrate that their actual building uses only a certain amount of energy and doesn't exceed certain thresholds. Either by posting bonds that after, say, a year out, they could get back if their building, in fact, only consumes that much energy, or maybe something in an ongoing way. This is, I would say, is mostly a theoretical idea at this point. There have been some attempts. I would argue that Tokyo is probably the most advanced, although theirs is through a cap-and-trade system. So there are no full-scale examples yet, but it's a really intriguing concept that a lot of countries are interested in learning about. Okay, so moving on to the implementation process and the different options. I think first it's important to say not all countries have a robust implementation process, and many countries recognize, in fact, all the countries we spoke with felt that they had a lot of room for improvement in their implementation process. Some of the elements that will typically show up, although they may not show up in, all three of these may not show up in each country, includes plan review. So that means reviewing the design of the building to see if it complies with the code. That's the most common. If countries are going to have any kind of an implementation process, most likely that's what they'll do. The next is on-site inspections, and that could actually involve multiple inspections throughout the construction process. It might involve extensive documentation to demonstrate compliance during the construction process, or it may not. Finally, it may involve some type of post-completion efforts like commissioning or blower door tests. Those are increasingly common, but the majority of countries do not have anything in that space. Also important to note, local governments everywhere typically play the key role in enforcing building energy codes. Compliance software can be a really important tool to help mainstream compliance. And also, one thing we found in the implementation process is that building material testing, rating, and labeling, while it may sound like a fairly technical topic, it's actually really important to make sure that you're achieving the results you want. Because if you think you're going to put in a window that has certain characteristics, and in fact the testing process is not as robust as you think, your window may not perform as you want it to in the end. So that's an important piece not to forget about. So next, moving on to government roles in the codes process. At the national level, many governments will develop the codes or provide training and resources. Australia is a good example of that. Canada, India, Mexico. In the United States, there's a model code that's adopted, sort of not at the national level, but at the national scale. It's developed at the national scale. And at the state, regional, or province level, in many countries, that's the level at which the code might be adopted, particularly for countries with a federal form of government or that have devolved some of the regulatory responsibilities to the state or regional government. So that's certainly true in the United States. Australia is in that situation, China as well. And then the local jurisdictions, as I mentioned, are typically responsible for enforcing the code. That's true in almost all countries. So then who is responsible for checking compliance? That varies a lot as well. At the design phase, many countries do involve local government, but I don't think that's actually the majority of the cases. Local government, there's the idea that this could be more robust because they may be more objective. There are also just limits on how many resources local governments may have. They may not be quite as expert in all the technical skills necessary to check a complicated building for compliance. Many countries have relied on third parties as well. Sometimes they may involve some review by the local government, like in the case of China, there's fairly extensive review, or it may be occasional spot reviews of, say, 1 or 2% of the buildings by the government, in addition to the third-party reviews. South Korea, we found that there's a national government institute that is involved in the design phase reviews. At the construction phase, and again, a lot of countries do not do construction phase reviews, or if they do, it's only sporadic. It's only a small % of the buildings may see construction phase reviews, including some of the countries mentioned here. And it may also depend on the jurisdiction, where some jurisdictions do it most of the time and others don't within a given country. So here again, it's a similar story. The local government may be involved in inspections at the construction stage in some countries, Australia, Canada, the United States. India has talked about that, although to date there really isn't significant construction phase inspection. Third parties may be involved in a lot of other countries. So China has a well-developed system of third-party reviews, France, and so on. And then again, many countries don't do third-party reviews or any kind of construction reviews. So the code revision schedule, I think, is also something interesting. What's the process to improve the code over time? We also looked at the extent of stakeholder involvement. I won't speak in great detail about that today, but if you go on the BEAT website, you can see more information about the stakeholder process in different countries. So we looked at 22 countries, and of those, only 4 have regular schedules for code updates. A clear revision schedule, in theory, can help industry plan and adapt. It can also facilitate more stakeholder involvement. And then, of course, most importantly, frequent updates allow for faster code improvements. So ensuring that some way or another there's a process to have frequent updates, I think, is quite important. And you see the countries that have some of the most stringent measures will have more frequent updates to their code every several years at least. In conclusion, codes are becoming more common and rigorous throughout the world. It's true not just in the developed world, but also in the developing world. And because they're being revised more frequently, they are getting more rigorous. Implementation is challenging everywhere. There are interesting examples in different countries of potential solutions. So collaboration is, I think, would benefit all of us because it is a complicated subject, but I do feel it's one where, you know, we can see important gains, particularly through learning from each other and working hard at this. Thank you.
Great. Thank you very much, Meredydd, for the presentation. And we will be turning now to Chen for his presentation.
Everybody, can you see my screen now?
Yes, we can, Chen.
Yeah, can you see my screen now?
Yes, we can see your screen. You'll just want to go to the slideshow view.
Okay, I'll begin. And I'll introduce about the building energy efficiency code in China, and it will include 5 parts. And from 1980s, China began to develop the building energy efficiency codes, and we start to name from foreign countries like US and like the European countries. That is before the 1986. And after 1980, we began to do some light demonstration and pollution the standards and the codes. And in the third stage, we think it's from 2001 and to 2005. We gradually made the code systems in different types of buildings in different climate zones, and after 2006, and the national has put the codes all around, and we can see this map. This is climate zone in China, and firstly, the in the civil code and the code zone, the building energy efficiency code was meant to improve the building envelope resolution, and then after that, in hot summer and cold winter zone, new codes was made for improve the building energy efficiency. After that, it's moved to the south part of China in hot summer and warm winter zone, and the building type for the code for the building types, well, firstly is just a focus on the urban residential. And after that, commercial and public buildings was they focused on the building energy efficiency. And just about 2 or 3 years ago, the code for rural residential buildings was developed. And firstly, also newly built buildings was be paid more attention than existing buildings. And the process was made will include laws and regulations permit for newly built buildings where we should be energy-saving buildings in China in most urban area, and the existing buildings will be retrofitted if no energy efficiency, and the energy saving for pollution level for energy efficiency and the data studies are also being done in China now, and standards and codes was gradually developed just during these years. Energy-saving technologies, the codes focus on energy-saving technologies will cover the prime design, construction, operation, and the retrofit period. And it includes the enveloping solution, natural ventilation, shading, HVAC, and lighting systems. There will be several laws and rules in China, like the energy conservation law, like the renewable energy law, like the building energy conservation ordinance, and the public sector energy efficiency regulations. Each different laws or regulations have different contents. Just to show in a table, for example, the energy conservation laws will include the energy management, energy saving technologies, and so on. And the standards or codes will include the basic standards, design standards, acceptance standards, testing standards, evaluation standards, and the transformation standards. These standard codes were made from 1986, and some of them has been reviewed for two or three times, and it covers different kind of buildings and different kind of systems. For example, the residential buildings, it has the standards or codes for residential buildings was firstly made in 1986, and its targets was save about 30% energy. And in 1995, it has been reviewed and targeted rise to 50%. And in 2001, the standard was made in hot summer and cold winter zone, not just in north space. And it was be developed in hot summer and warm winter climate zone in 2003. And in 2008, the home country has been made the residential building codes. The target was rise to 65% in several cities like Beijing, Shanghai, and so on. From 2011 to 2020, the whole country will make the target to improve the energy efficiency of the buildings to save energy about 65%. Several countries like Beijing, Tianjin, Shanghai will improve the energy efficiency to save about 75%. And from 2021 to 2030, the whole country's standards or code for residential buildings will include passive house, green buildings, ultra-low energy buildings, near-zero energy buildings, and so on. And for the C and P buildings, in 2005, the whole country made a standards for the target is save about 50% of energy. And in 2015, just this year, the new standard was be reviewed for the home country and has made more details about the systems and about the different systems in different climate zone. And what China does to make the code recommends is stage by stage, and we established different systems for new buildings or existing buildings and for local government. And it will be updated for up to the improvement of technologies, some new products or some like building enveloping solutions. And the EEB energy efficiency building public training and tech exchange and global cooperation will be done in some university like in Tsinghua or like in CAVR, some research institute. So maybe that's just a brief introduction about the Chinese codes and standards developed. Thank you.
Great, thank you very much, Chen. We will move ahead now to our next presenter, Mr. David Cohan.
Okay, whoops. Hello, everybody. This is David Cohan. I'm speaking from the U.S. Department of Energy in Washington, D.C. And hopefully you can all see my screen now.
Yes, we
Could you
can.
verify that, Sean? Okay. I'm going to give a very brief overview of the various code phases in the United States. The basis of the energy codes that's used in almost all the states are developed by two nonprofit private organizations. So one is ASHRAE, which is a very large volunteer engineering society, and they developed something called Standard 90.1, and that's for commercial buildings only. And then a totally different group, the International Code Council, develops what's called the International Energy Conservation Code, which includes both residential and commercial buildings. And these groups run public processes. Anyone can participate. So in general, they're on a 3-year cycle. Meredydd mentioned earlier the frequency that countries change codes. So in the United States, historically, it's been every 3 years a new code is developed. And anyone can participate. You don't need to be an expert. You don't need to be nominated. You submit code change proposals, and then those are reviewed by a committee, and the process varies depending on whether it's ASHRAE or the International Code Council, but ultimately a vote is in, and whatever is decided to change from the last code becomes the new code. The U.S. government participates in these processes, but we do not have any special status. As I mentioned, these are private nonprofit organizations. So we are one of many stakeholders. Many people from industry participate, energy efficiency advocates, government representatives from state and local governments. Lots of people participate. One of the really important things to understand is that ASHRAE 90.1 and the IECC are model codes. So there is no national code in the United States. And a model code, the best way to think about it is that it's just a resource that's available for a government to adopt. Nobody is forcing it to adopt that. And in fact, if a state wants to adopt a model code, they can also change it however they wish. States and in some cases local governments can even develop their own codes. California, which is the largest state in the United States, has its own code, and they do not use these model codes at all. In most instances in the United States, codes are adopted by state governments. In about 10 states, the individual cities adopt codes rather than the states. And when the states or the cities adopt a code, they run a public adoption process very similar to the ones that develop the national model code. They send out an announcement that says, we are thinking of adopting this new code, and they invite people to participate and to submit code change proposals, and then there are committees that vote on them. And when the voting is all done, they have a new state or local government code, and usually after they adopt it, they give people about 6 months before it's required to follow it, so that people who design and build buildings have a chance to understand the new code requirements and make the changes necessary. So the U.S. codes cover the building envelopes, the walls, floors, ceilings, and windows, lighting both on the inside and the outside of the building, daylighting, and mechanical systems for heat recovery and control. Things that are not regulated are process loads. So things like factories in industrial facilities in general are not covered by the building codes. Also plug loads, so appliances and electronics are not covered. And most important, the efficiency of equipment is not covered in the building code. The national minimum equipment efficiency standards are created by a completely separate process by the U.S. Department of Energy. And there's actually a law that says that a state or a local government adopting a code cannot increase the minimum equipment efficiency. So it gets a little interesting that obviously the codes affect the energy use, but a very key component, the equipment itself, is determined by a different process. However, the code can control the systems. For example, the controls. If you want, for example, the code would say you have to insulate hot water pipes, even though you can't determine the efficiency of the water heater. Anything that's not the equipment can be regulated by the code. I'm going to show you two charts now, the first one for residential and the second one for commercial. And this shows how much energy savings have increased over time. So the bottom of the chart is time starting in 1970 about, and the left-hand vertical axis is the easiest, it's EUI, which is energy use intensity, but it's easiest just to think the amount of energy that these buildings can use. And what you'll see is that from about 1975 to 1985, almost nothing happened. And then there was a big jump down in 1986, and then things sort of went slowly downwards over the next 20 years. And then in about 10 years ago, we had two codes in a row, and these are the model codes, two model codes in a row that had major energy savings associated with them. And we're still now sort of getting those adopted and implemented in the states. I didn't mention it earlier, but the model codes are adopted by about 40 of the 50 states in the United States. So while they are not a requirement, they are very important in determining the codes in the country. Okay, the next slide is commercial buildings, the same kind of slide. And you'll see that, again, there was a long plateau in the beginning where very little energy was saved. But in the last 10 years, the codes have improved dramatically. Okay, after a government has adopted a code, you need to implement it. And the first thing that usually happens is that my program at the Department of Energy creates educational materials that explain the difference between the old and the new model codes, and we also provide software that makes it easy to show compliance. And then most states will use these materials, and they will provide classes to both building officials and design and construction professionals so that they can learn what's changed in the code and change their own practices so that they comply with it. There's also states that do field research to discover if buildings are complying with the code. And that's different. In almost every state that has adopted a code, the people building the building have to pay a fee. And that fee covers a review of the plans and then usually multiple inspections on site at different times. So they will go very early in the construction process to see whether the foundations have been insulated, and then they'll go later to see if the walls have been insulated and the windows meet the code, and then they'll go at the end and do a blower door test and a duct leakage test to make sure that those meet the code's requirements. So in almost all cases, there is on-site inspections, but then above and beyond that, some of the states afterwards go out and do research to find out if everything's really working. And that's all I had to say. Free to answer questions afterwards, but thank you very much.
Great, thank you, David. And we have had a number of questions come in. Before we get to those, I would like to turn things over to Peter Graham, who's joining us, and he will address some things before we address the attendee questions.
Okay, thanks very much. Can you hear me okay?
Yes, we can.
Okay, perfect. Well, first of all, thanks to Meredydd and Ken and David for really interesting presentations, and also Jonah for setting the scene. It strikes me that one of the key issues really that's coming through is really about getting the actual energy savings out of real buildings once the codes have been set in place. And with the wealth of experience on the panel, I'm just wondering whether you have seen any common approaches which really work. I mean, clearly there are different contexts in each of the places that we've heard from today, but getting down to this question of implementation and achieving the energy savings which are pretty much on the table with regulations that are in place, I think is a key issue. We found with the GBPN, as we work to try and help governments adopt best practices, that often the failure to be able to realise energy savings that are currently mandated in existing codes becomes a political barrier. So I think this is a really key issue, and it'd be interesting to hear more from the panel about that. And the other issues which come up, which might be related to, or barriers to achieving proper full implementation, are things that complicate the implementation of codes, such as this question of the integration between different levels of government, and also, as we've heard from David, the integration between different forms of codes and standards, whether they be building codes and appliance standards, or materials, performance standards, and so on. So I guess they, to me, seem to be issues which are common, which are perhaps even embedded somewhat in the codes process or a factor of the building sector. But it'd be interesting to hear more from the panel about how you can address implementation and this integration in such a complicated market. Thank you very much.
Great, thank you, Peter. Did anyone want to address some of the points that Peter raised before we move to the attendee questions?
This is Meredydd, and maybe I'll make a brief comment. I think it is just consistent hard work in having a system to check buildings, to check the plans. It doesn't have to be local government. It can be coordinated with third parties, but carefully thinking through the model to make sure that it's robust and objective, and then also evaluating the process. Having some way to check, are you actually getting the results you want? And to feed that back into your implementation program, and also ultimately into your code revision program. Because if there's certain things that are really challenging for people to implement, maybe there's a different way to phrase it. Maybe there's a different requirement that one could have. Thanks.
And this is David. Peter mentioned politics, and I guess I would also say attitudes are important. So building codes are much broader than energy. There's electrical codes and structural codes and fire codes. And one of the problems we have in the United States is that the building officials who are in charge of inspecting the buildings and reviewing the plans often think that the energy code is not as important as those other codes. So they give it less resources and less time, and that makes it difficult to make sure that everybody's meeting the requirements. That's a much harder problem to solve, but we just know at some point culturally we need to get people to believe that the energy codes are just as important as all the rest of the codes if we want to see these implemented properly.
Great, thank you both for the additions. And it looks like we can move on now to some of the questions from the attendees. I'd like to start with kind of a broader, more high-level question. We've had a number of people ask how codes can be developed from scratch. Obviously, that's a pretty detailed question, but maybe we could give just a broad overview of that. Again, a number of people have asked that. What is the first step in developing and building energy efficiency code, and what are the first steps for implementing them when there's none to begin with?
This is Meredydd again. Yep. Go ahead.
This is David Cohan. I think the easiest answer to that is you should never start from scratch, because there's lots of good work that's been done all over the world, and what you want to do is take a look at other countries' codes, and it'll take a long time, but you need to set up a group of people whose job is to review those codes and determine what parts are relevant to your country and what parts are not relevant to your country, and then both add things where necessary and remove things that are not necessary. But it would be way too much work to start from actual zero, and there's no reason to.
Yeah, Peter endorsed that too, David, and we've done a lot of work looking at best practices around the world, and there are a lot of resources for a range of organisations that can be tapped into to avoid starting from scratch. I think that's a really good point. That also goes for the kind of data required to begin developing your codes program as well. There's quite a lot of data on building energy intensities, etc., which could be used as a basis as well. So just endorsing that, you don't need to start from scratch. Please don't, is also a plea, I guess.
Yeah, and this is Meredydd. I agree. There are a lot of great resources. I think some key steps are bringing together the stakeholders and coming up with a plan. How do you want to go about this? What are the codes you might refer to? But then also thinking, you don't have to start by requiring strict energy efficiency measures in every single building. You can start with a piece where you can test out your implementation in a way that builds your confidence, builds the market's confidence. Maybe you're starting with larger buildings, but then if you do it that way, make sure you have a clear roadmap for how quickly you're going to expand so that it doesn't become difficult later on. I think baking that in is important.
Great, thank you, everyone. Moving on now to the next question. It states that typically the penalty for non-compliance is non-issuance of construction permits. So for outcome-based codes and codes with post-completion requirements, such as commissioning, typically what is the penalty for non-compliance?
So I think that that's the crux of the issue, really. I would also add that it is not universally true that non-occupancy is the typical stick. Different countries have very different approaches. Sometimes they have fines. It is not universally true that countries won't let people occupy buildings that don't meet the energy code. In terms of outcomes-based codes, so I go back to the example of Tokyo, which is not technically speaking an outcomes-based code, but it has many of the same features in that they're monitoring energy use in all the large commercial buildings over time, and the buildings have to stay within certain caps that are declining over time. And basically what happens there is it's a carbon cap and trade system. If you do not meet the requirements, you have to either buy credits from someone else using money, or you have to find ways to invest in energy efficiency measures or some combination. David may want to speak about some of the models that have been discussed in the United States. But.
Yeah, it's a little awkward in the United States because there has been a great deal of discussion about it, but there are very few actual examples where it's been implemented. The main one was Seattle, and it did not really do very well. But I think part of the answer to the question is that the outcome-based codes are on top of the design and construction code. They do not replace them. So what you want is a good design and construction code, and you can just leave your current system in place. But then the outcome-based, maybe even different government agencies who monitor it and enforce it. But you really don't want to, what you don't want is to let buildings be designed and built any way they want, that people want to, and then hope that afterwards they'll perform properly. So exactly how you do outcome-based codes and how you motivate people to do them, it's a separate process, to me, is the most important thing to keep in mind.
Great. Thank you, Meredydd and David, for the response. And now we have a question that came in, this one specifically for Chen on his presentation. And Chen, it asks, in your presentation, in terms of improvement, you mentioned that for example, the residential buildings, the target for 2021 to 2030 will be 75%. Does it mean 75% of buildings will be energy-saving buildings, or 75% energy savings overall?
Thank you for your question. And this target is for the newly built buildings. And compared to 1980s scenario, the new built buildings will save about 55% of energy. So it's determined for the newly built buildings energy efficiency. It's not for the how large floor area of the energy efficiency building take part. It means the energy efficiency target for newly built buildings.
Great, thank you, Chen. And another question for you was, are there any plans to line up greenhouse gas reductions and savings being caused by the construction industry? Is there any plans to match that with the energy efficiency code?
Beg your pardon? You mentioned the green building code?
Yeah, they're just the attendees wondering if there's any plans to line up greenhouse gas reduction savings as a result of the energy efficiency codes. Are they tracking greenhouse gas reductions from the codes?
Yeah. You mean for the green buildings, what's the target for the energy savings for the green buildings, right?
Yes. Yeah, so they also track emission reductions.
Okay. Green buildings in China may, green buildings in China will have their lives for 1 star, 2 star, and 3 stars. And the target for different levels of green buildings, well, it's not just include save energy, but also save the land, water, and save the materials for the buildings. And it's target for the promote the nature protector. So the energy efficiency is just part of it. The target for the green buildings maybe is compared to the energy saving codes, just mentioned that in 2000, like for example, in 2008, the target for the energy saving for residential is about save 50%. So the green buildings in that time is target is for save 50% for green buildings. It's the same with the energy saving buildings code. It's not just, but it includes any more some more contents.
Great, thank
Is
you.
that clear? Yeah.
Yes. Yeah. Thank you. And Meredydd, I think this was directed towards you, but I think it's something that everyone could address as well. So it's really for the whole panel. What are the major incentives for local governments to enforce codes, assuming that most local governments have to find a balance between social benefits and building developments and owners?
Great question. I think that they're similar to those at the national level. So it's reduced strain on energy systems. It's homeowners and businesses that can be have lower cost, and in the cases they're more productive. It's the fact that there'll be lower emissions, which in some cities is a very important issue. So I think it's at a smaller scale, but they're the same reasons that governments care about building energy codes overall. I think, as David had mentioned, the key is getting the individual code officials to understand that these issues are equally important to whether a building is likely to burn in a fire or likely to stay standing because it's structurally sound. These are not peripheral issues if we can come together and finding ways to implement the code robustly.
Yeah, and I'd like to add something too. I think when you look at some of the experiences from jurisdictions in European countries, particularly with implementing energy efficiency codes for retrofitting, you see that there's quite a good link between energy efficiency codes and creation of local jobs in the construction sector. And so there's a co-benefit in terms of job creation. And another important issue which is coming up is the issue of urban air quality. And often, in some countries at least anyway, reducing energy demand from buildings can help reduce air pollution. So there are a range of other multiple benefits as well, which really do accrue at the local level and not so much at the state or the national level. Thanks.
Thank you, Peter and Meredydd. And this question is for David. David, do you know what the current code adopted in California is?
Well, its name is Title 24, which just refers to the name of the law. And I can only say that it's better than the current model code, the most recent version of the model code. But beyond that, I can't tell you any details of it. It's available online. If you just Google Title 24 California, you can review the whole code.
Great, thank you, David. I'll send that title to the attendee. And moving on to the next question. One of our attendees just wants to thank you for the overview and the background and asks, what are the next, if you could outline the next key steps to improving implementation overall? And obviously this one's for everyone.
Yeah, this is David. I think I have to go back to what I said about trying to get people to care more about the energy code, because that's really the key to the whole thing. In the United States right now, the current version of the model codes are pretty good from an energy efficiency point of view. So if we could get everybody to adopt them and everybody to enforce them seriously, we would save a lot of energy. So it's really just getting what we already have in that exists already into place and enforced on a regular basis. And that we do some of that through education and training, but there also needs to be, a call from policymakers to make people aware that this is important and that the government people in charge of it need to pay attention and take it seriously.
This is Meredydd. I completely agree with David, and I would also add that evaluation can sometimes help in this process. I've seen some jurisdictions that feel like they have a pretty robust process, but they have no information on whether people are actually adopting the code or not. And if you start to understand what is working, it can help you improve that process. It may also help in engaging the local officials who need more hand-holding or more information to be able to understand why there are benefits here.
And I'd like to add, sorry.
Oh, okay. Yeah, sorry for jumping in. Another thing too that we found is helpful is our US partner IMT has been running an awards program for local code officials. So if a code official has done very well in implementing the energy performance code, then there is an award for them. So I think part of it is education and awareness raising, but I think also, anything that can be done to demonstrate to the code officials that this is really important, such as an awards program, something like that. It seems to be working. It's not every day that a codes official gets an award for implementing the law, but it seems to be something which we're seeing as welcome in the US at least. So that's something to consider. And I think also, just to back up Meredydd, the point of evaluation and looking to collect data on the existing energy performance of buildings to either to help with the political argument demonstrating the need for a code. It's very important, and also, of course, how important it is to implement it properly. But then also going back to check to see that buildings are performing according to code improves the code, but I think it also provides a key element of motivation for officials and also for governments to continue to push forwards. Finally, I think just looking at the example of China, and again, the GBPN's done some reviews of best practice jurisdictions around the world with respect to building codes for new buildings and also for existing buildings, but particularly for new buildings, the idea, the key, one of the common elements for success, I should say, is setting targets, setting long-term, medium-term and short-term targets for improving the performance of building stock and reflecting that in codes and making sure that the changes to the codes are communicated in advance to the industry so that the capacity building awareness raising can happen to enable implementation when the new performance standards are come into force, etc., is really important. So getting back to what Meredydd said about having a plan is really key, but also having that plan with quantitative targets and sort of projection of increasing stringency over time, I think are elements which we've seen to be components of successful jurisdictions.
Okay, thank you, everyone. We'll move on to the next question. We do have quite a few questions left, so we'll try to get to as many as we can. Next question builds on what was stated before about looking at what other countries have done as a first step for implementing energy codes. It asks, what are some reliable resources that the panel would recommend to review what other countries have done?
I would strongly recommend going to the B3 portion of the GBPN website, because there's quite a bit of information there on the 22 countries that we looked at, and so that I think is a really helpful resource. Also in that web portal, there are links to other documents, other reports that have looked at early stage code adoption in different countries, and so on and so forth.
This is Jonah as well. I'll just add to that. There's also a, in addition to the resources page and the summaries of code implementation practices across the countries, there's also lists of code experts from around 20 different countries who have made themselves available to be sort of resources and help answer questions, point people towards more detailed kinds of resources within their country. So, you know, use that as another resource as well.
Jonah, is that also, oh, sorry, just follow up. Is that also on the GBPN website?
It is. It is. There's a directory of experts tab on the GBPN B3 portal site.
Great. I will send that out to the attendees.
Yeah, and just a couple of other things on the GBPN site. So there are two tools, one on best practices for building codes for new construction, and another for best practices for residential renovation energy policies. And this gives, these two tools just give you a way of being able to compare different jurisdictions' approaches to building energy codes and across a range of best practice criteria, so that they all come with case studies and other things. But I'd also, and the resources there are also available in Mandarin as well. So if you are looking at the site from China, then the resources available in that language. But also, I mean, there are a whole range of other really interesting resources out there on the internet. Just off the top of my head, I'd refer also to the European Commission and the build-up web resource, which is actually quite good for renovation policy, and that also gives a range of resources for the Energy Performance in Buildings Directive, which is very interesting. There's the BCAP for the US, the Building Code Assistance Project, which I think is also a great resource for the US codes. But I'm sure once you get into those resources, you'll find links to many others.
Great, thank you everyone. I did send out a couple of those links as well. Moving on to the next topic, could you please share any encountered challenges and successful implementation tips of compliance software for energy efficiency codes?
Go ahead, David.
Do you want? Okay. There's two pieces of software, one for commercial buildings and one for residential buildings. And if you'll remember, I said that states and local governments do not have to adopt the model codes as they are. They can amend them if they want. And then, of course, every 3 years there's a new model code. So there are some difficulties in having all the versions you need to accommodate the states and what code they've actually adopted. And we get a lot of requests from a state who has changed the code in some way, and they say, can you make us a custom version of the software? And sometimes we can, but there's a resource issue. So to me, it's just, you will have to deal with many different versions of the code, at least if you have a system like the United States, and that's probably one of the hardest things we have to deal with.
And this is Meredydd, adding on from some of the things we've seen internationally. first, it's really important to have compliant software. If you have a code that has, in particular, if you have trade-off requirements. So think about that as you're designing your code. I've seen many countries that don't have robust software, and it really does stand in the way of implementation. Next is some countries want to build in whole building simulation into their software from the get-go, and it's really difficult to do it well and in a robust, replicable way where you get the results you want consistently. And I would argue don't worry so much about that. You know, worry about the other elements of the code, assuming that your that your code is, you know, has prescriptive, trade-off, and whole building paths. And you can use other commercially available software to do your whole building simulations as long as you have clear simulation rules in your code. And so that would be the thing to focus on there. And then finally, a robust library of building materials. That is a challenge in a lot of countries that are fairly new to this. And you know, you can look at other countries' libraries as a starting point, but putting some effort into learning about the properties of typical materials that go into buildings so that your software can run on those is really helpful. Most building designers really have no idea what the average U-value of a wall assembly is, and so don't make them do that guesswork. Thanks.
Thank you both. And we have a couple related questions. I'll try to word this to capture both of them. They're basically asking what is the relationship between outcome-based codes and benchmarking in disclosure, and also along with that benchmarking and disclosure, what kind of monitoring usually needs to be put in place to make sure that codes are being met.
So outcomes codes, the basic concept, and again, it has not been implemented at scale anywhere that we're aware of, so it's a concept, but the idea is that it would incorporate benchmarking because you have to have some way to tell if a building is meeting the outcomes that it would like, but it goes beyond that because it has specific targets and presumably some carrots or sticks associated with matching your desired target. Disclosure, you know, an outcome-based code does not have to have disclosure, and could or it couldn't. And different models for outcomes-based codes people have talked about would involve, most in North America have talked about a fixed period of time where you'd sort of check the building for a year or so after you've built it to make sure that the consumption is as you expect it to be, but it's not an ongoing basis. You know, I mentioned the example of Tokyo where it is ongoing, but it's not technically an outcome-based code either exactly.
Thank you, Meredith. And we have time for a couple more questions. Do you have any cost-benefit estimates of implementing building energy codes? Just in general, not any specific numbers, but.
We have on energycodes.gov, which is the Department of Energy's website, you can find a report called the National Benefits Assessment, and it does cost effectiveness over, it's a 20-year, I think from 1992, or maybe a 30-year, 1992 to 2020, I think. And we will be redoing that next year. And then various states have done their own cost effectiveness, and we have provided those analyses actually to every state. It's safe to say that in general energy codes are extremely cost effective because it's much cheaper to change a building during the design phase than it is to change it after it's been built. So that there are resources out there, there are methodologies out there that people could look at, and you would just have to find something that makes sense for your situation.
This is an area where we've heard a lot of interest in collaboration between countries. What are the methodologies you use to assess costs and benefits? Because it's required in an increasing number of countries, particularly in the EU.
Great, thank you, Meredith. And actually, building off that, we did have one person ask if you could give a very brief status on the codes in the EU.
I can try. I don't know if Peter, if you want to jump in on it.
Yeah, I could. Well, I just give you what I've seen. I mean, I refer you to the Building Performance Institute Europe, bpie.eu, for a whole range of detailed analysis of the implementation of the European building codes under the EPBD framework and also the energy efficiency directive, www.bpie.eu. And I can tell you from reading some of their analysis that there is still a ways to go for many member states in achieving the EPBD nearly zero energy targets, and also and probably a lot further to go for many member states in developing energy efficiency renovation roadmaps that are required by the Energy Efficiency Directive.
And if I could add on to that briefly, so I think generally speaking, in Europe, the codes in most countries are integrated related with building energy performance certificates under the Building Performance Directive. So some codes have had more requirements historically linked to, having a certificate that shows what the performance theoretically might be than requiring specific efficiency measures. That is changing. Broadly speaking, there are stronger codes as you move north. It's not universally true. Some Scandinavian countries have very weak codes. Some have excellent codes. Southern Europe typically has not had very strong codes. And Eastern Europe as well, or Eastern or Central, tend to be less strong than looking farther west. There's been a lot of change in this space in the last even 3 years. France has adopted a new code and worked much harder on implementation, et cetera.
Great, thank you, Peter, and thank you, Meredith. We do have a number of questions left, but unfortunately we are running low on time, so we're going to move ahead now to the next section. But I do want to just reassure everyone that I have all the questions here, and I will email those out to our speakers. So give them some time to respond, but we will be able to address those in the near future. So with that, I would now like to move ahead to a quick survey that we have for our attendees, just to help us evaluate how we did on the webinar and improve for future webinars. So I will go ahead and display the first statement. If you could please respond directly in the screen. The statement is: the webinar content provided me with useful information and insight. Great, thank you. And the second statement: the webinar's presenters were effective. And then the final statement is: overall, the webinar met my expectations. Great. Thank you, everyone, for responding to our survey. And again, just a reminder, if we didn't get to your questions, my apologies, but I will be emailing those out as well. So with that, we'd like to go ahead and wrap up. And on behalf of the Clean Energy Solutions Center, I would just like to once again thank our panelists for joining us today. Great presentations, and also I'd like to thank our attendees for participating. We do appreciate your time and are happy you were able to join us today. And I invite the attendees to check the Solutions Center website if you'd like to view the slides, which are now posted, and also listen to a recording of today's webinar, as well as any previously held webinars. Additionally, you will find information on upcoming webinars and other training events. And also, just a reminder, we're posting all webinar recordings to the Clean Energy Solutions Center YouTube channel, so please go ahead and check that out as well. It will take a few days for today's recording to be posted, so check back either tomorrow or the next day. We also invite you to inform your colleagues and those in your networks about Solution Center resources and services, including the no-cost policy, Ask an Expert policy support. So with that, I hope everyone has a great rest of your day, and we hope to see you again at future Clean Energy Solutions Center events and webinars. And this concludes our broadcast.